All right, today I'm going to talk about horizontal projectiles. They're interesting. So here is a building or something off which I throw something off. And the first thing I want to do is give you some intuition on what the motion would look like. And so we all seen that it kind of makes a curved path like that. Seen a ball roll off the edge or be thrown off. I'm going to assume it's got zero velocity in the y direction as it goes over, which is why we call it a horizontal projectile. And so you know that as the ball falls, there are no forces in the x direction. So if it came off with a x velocity of say 5 meters per second, it would be always the same throughout the entire motion. Okay, right till it gets to the end. There's nothing pulling or pushing this way to make it go any faster or slower. However, gravity does make it go down faster and faster. So at first we get a little y component of gravity, call it Vy, which gets bigger and bigger and bigger. And you know how to calculate this velocity using the kinematic equations that we learned for free fall. And you can know how much this velocity vector is going to be at any instance, 1 second, 2 seconds, 3 seconds, 4 seconds after, excuse me, it's been launched. And so those are a couple of things I just want you guys to see, that there is a x motion and a y motion. In the x motion, there's no forces, no acceleration of any kind. So we go back to using our simple equation, which was that velocity equals displacement over time. However, for the y motion, this is for the x, for the y motion, we have a constant acceleration, so we have to use our kinematic equations. Okay? So, give some more kind of fun reason, like why would you want to learn horizontal projectiles? So let me make up a problem and then we'll see some fun avenues. You got a car that you're driving in, and you need to go over this cliff. There's a river here, and you want to make sure that you cross the river. And so, you're a scientist, so you got out of the car first, you figured out the angle it was to the edge. One thing you knew was the height of the cliff, so you could then use trig and you figured out the width of this. And so let's say you knew that the cliff height was, let's make it 40 meters. It's pretty high. And let's make this 45 meters. So you gotta drive pretty fast to go over. So you're gonna land here, and of course you're worried that, hey, I don't want to go too fast, or the fastest the car can go, because I might just kind of mess up and bust my car and not be able to get the rest of the way home. So again, the question would be, how fast do I need to drive this car off the cliff so that I can make it, but not too fast that I break it, okay? So, do some physics. All right, so we said that there was this different kind of physics going on, kinematic equations or normal speed, distance, time, or velocity, displacement, time kind of equations. And so, hey, we are going to have to look at the x and y motion that's going to be happening with this car going over the cliff. And so we separate them out. And this is the way I want you guys to start working on these questions, is you separate them out. What happens in the x stays in the x. What happens in the y stays in the y. So all your y variables are here. All your x variables are here. You separate them out. Okay? except for time. Time is like a ninja, can go through walls. So the time can hop across, but the x and the y coordinates, the dimensions of space are kept separated. Okay? They're tied together by time. Okay. So when I sit down and I do my physics, I say, okay, how long is this car going to be in the air? Because how far it's going to go, the x direction, I know that my delta x has to be my v naught times time, right? Meaning my delta x has to be my velocity times the time that it's in the air. So I need to figure out how long it's in the air. I know my delta x is equal to 45 meters. That's how far I got to make my delta x. When this comes from here to there, my x displacement is 48 meters. My y displacement will be negative 40 meters. I hope you all know why it's negative. Okay. And so what else do I know? I know my acceleration is going to be negative 9.8. I did mention this was happening on Earth, right? And I know my VI in the y direction is 0. I am not putting VI y because this is, don't confuse this with this velocity. This is the x velocity. It's not changing, so I don't need a VI and a VF over here at all, do I? I just need to deal with these variables, these ones here. So, back to my little table. I know that now I can figure out time because I have 3 variables here. And once I know this time, I can plug it in here and figure out my delta x. So if I don't know my delta x and I know the t, I can use this equation that v naught must equal to delta x over t, and that would tell me how fast I need to drive my car off. So let's do some math. Since I don't have my calculator, I am going to pretend that g is not negative 9.8, but negative 10 meters per second squared. Just for fun, just for today. It's approximate enough, isn't it? Okay. This is what you can do when you're playing around and you don't want to go and fetch your calculator. All right, so when I figure out time, I know that my VI is 0. I'm using delta y equals VIT plus 1/2 AT squared. That's because those are the variables I have, and that's the only one that's going to work. And so I know this is 0 because my VI is 0. So I need to write that term. I'll just write down delta y equals negative 0.5 times 10 times, now you know I picked 10, times t squared. All right? And so delta y is equal to this. We can say then delta y, of course, was negative 40. So negative 40 equals negative 0.5 t squared. I divide both sides by negative 0.5. That becomes negative 80 equals t squared, negative t squared. Or these negatives cancel, so just make them all positive. So t would equal to the square root of 80. Okay, which, if I were to ask you to guess how long that was, you would say, I'm sorry, I made a mistake here, that's 5. That did look like the time was going to be too large. So that's 5. So I'm going to divide both sides by 5, not 0.5. Let's get that out of there. Negative 5, negative 5. I multiplied 0.5 and 10, I made 0.5. Silly me. Okay. So, divided by negative 5, divided by negative 5. So that gives me 8 is equal to t squared. So t is going to be equal to the square root of 8. And then that, you guys can kind of guess, would be about, now you see why I went back and said, that doesn't make sense. That seems too long 40 meters. I've dropped thing 40 meters. It doesn't take anything that's like 7 seconds. It's far more like, you know, maybe 3 or 2 seconds. So square root of 8, which you would know would be, you know, some number between 2 and 3. 2 times 2 being 4 and 3 times 3 being 9. So, you know, larger than 2.5. So some number thereabouts. We just say t is equal to square root of 8 seconds. We know it's a number. We can easily figure that out. Okay, so now I can figure out that my velocity would equal to delta x, which is 45 meters divided by square root of 8 seconds. Okay, and that gives me the meters per second that I need. And so with all of this stuff said, I'm going to take a sec and go get my calculator. Okay, I am back. So square root of 8 is 2.82. So 45 divided by is 50. Square root of 45 divided by square root of s is 15.9 meters per second. Okay, so that's how fast you need to drive your car. Let's see, if I were to multiply that by about 2.25, I guess about 36 miles per hour. Okay, so that's the speed at which you want to drive your car off. So you get it to the constant speed of 36 miles per hour, and that gets you right over there where you make it and not break it. Okay, if you had gone saying, hey, I'm just going to go 50 miles an hour or 60, or because I can go 80 or whatever, then you probably would have landed somewhere up here, but then crash your car in the process. Okay, so here's where this can be useful. I'll do the next one with my calculator beside me and work this through and show you all a couple of different things. In this case, we were given the delta y and the delta x, and we had to figure out the time and the speed, the initial speed with which we need to drive off with. And so if we were to be given 2 other variables instead, for example, if I gave you the speed at which you're driving off, and you want to know where exactly am I going to land if I'm falling off at that speed. So it's just basically still using the same kind of table, just knowing what you have when you start, and then knowing that T, the ninja, can jump across like he did from here. We said it was square root of 8 seconds. So, you know, we can easily see that T jumped over here, and so that delta x could use it to make its find its v naught. Okay, so I'll do a second video on horizontal projectiles next.